So this is week 2. We will start with basic electricity. We're in chapter 2 in the book. I will go as slow as possible. I don't mind spending 4 weeks on the basics because we got to start with the rules. If things do not make sense now, it's going to be harder later on. So I'll go slow. If something doesn't make sense, please raise your hand. I'll try to explain. And we will go with a very, very basic concept. So hopefully it will make sense. And if not, I'll make it make sense. Okay, so we'll talk about the relationship between physical objects and electrons. What is electricity? How do we find out electricity? How do we deploy that for our benefits? How we use it now everywhere and every aspect. So it's a great discovery. It's always been there, but we discovered electricity. Why do we need to understand electricity? If you understand electricity, you will know how to work with it. You will know how to transfer it. You will know how to generate it. And again, it's very useful for us to make mechanical power, to make electronics, for our communication. We depend on it greatly for our civilization. I mean, if you think about it, if you eliminate electricity, you go back to the Stone Age. If you just eliminate electricity, nothing will work. You can't even get oil because you can't get even pump to work electricity. So we depend on it greatly. So it's very important to understand how it's functions. 4 types of electricity generation. How do we generate electricity? We'll talk about those. Some of them are ancient, some of them are modern. So there are 4 types and there's more. And people are coming up with ideas to generate electricity. We also want to talk about conductors and insulators, which is non-conductors. And we'll talk about also semiconductors, mainly silicon. So we'll move on from the basic. I'm sure all of you got to study or look at some science in high school before that, and we know that everything is composed from atoms. We agree about that? Atoms are there. We're not going to go into chemistry too much. I want to just explain the relationship. Our body is composed of atoms, our cells composed of atoms, and everything in the world is composed of atoms. The atom is composed of nucleus, which has protons and neutrons. And around every atom there are spinning objects called electrons. We still do not know all the details about these little components. We know how they function, we know their charge, but scientists are spending their lifetime trying to know what is it composed of. Till this day we do not know what is gravity, what is mass, what is energy. These are questions for scientists to think about. There are like a lot of projects like the Hadron Collider, CERN, to try to find out what is a proton. Nobody knows what is a proton. What gives an atom's weight? We don't know what its weight. We just know it's energy. Everything is energy. And relatively speaking, there's nothing. So we still don't know a lot of things. This is for scientists to think about, and it's going to be a while. For our intended purposes, we just want to know there are protons and neutrons, and we want to know their charges. And this, for us, works because it has been working for the last hundreds of years. So neutrons have a neutral charge, no charge. So there is 2 things. There is mass and there is charge. Protons, they have mass, and they also have charge. What charge is it? Positive or negative? Positive. And we know that electrons have no mass. However, they have the equivalent amount of charge to the proton in the opposite, which is what? Negative or positive? Negative. Okay. So we know mass and positive charge. Okay? And electrons, no mass and negative charge. We're happy? You got that down? Okay, what has mass? Proton. What has charge? Electrons. And electrons are spinning around this mass, which kind of mimic how the moon spins around the Earth, and how things that has larger mass have bigger gravity and things spins around them. So when we talk about quantum physics, it's about very, very small things and very, very big things, and they're all related. Again, we want to focus on what we need to know. Let's not divert too much. Electrons, the amount of electrons, the number of electrons spinning around a nucleus has something to do with the proton charge, because the atom wants to be stable. So if you have 3 positive charges in the center, you want 3 electrons spinning, just to be neutral. Everything in the universe wants to be at balance, right? But water at high level want to go into low level. High pressure want to go to low pressure to reach equilibrium. Okay? Few chemists try to think about how do we organize these atoms and matters. We have plenty of matters. We have metals, we have wood, we have biological matter, we have carbon. So let's make a system. If they're all made of the same material, let's make a system for that to make it easier for us to understand how they function. And they come up with the periodic table of elements. Of course, the periodic table of elements is man-made. It's us to understand how material matters. And supposedly it has all the material available on Earth, and they keep adding to it. Every few years they find new elements. You don't have to know about this. I'm just showing you so you can understand. We have atoms. We want to know what is a conductor and what is a non-conductor. Right off the bat, what would you think are conductors? Things that conduct electricity. Huh?
Electricity conductor.
Yeah, like what? Give me an example.
Fabric.
Copper.
Fabric.
Not fabric.
Get out of your car, you got a little electric
That's
shock.
static. I'll explain that, yeah. Silver. So what do we group this as? Metals. Okay. Let's look out of here. These are metals. So the periodic table is organized based on the amount of electrons in the last orbits and based on the weight. So if you look here, these are all metals. Okay, so we're happy with that. We look at the other side, we have non-metals, and the middle we have semiconductors. So the periodic table is organized based on the number of electrons in the last orbits. Again, I don't want to get too much into it. Electrons go in orbits, orbit 1, orbit 2, orbit 3. If this is the nucleus, this is orbit 1, 2, and 3 electrons. And which one you think is easier to knock out? The one in the closer orbit or the outer orbit? Outer orbit. Okay, let's keep it simple. So this is 1 electron in the last orbit, and this is 1 electron in the last orbit. So it's easy to knock out. These are our metals, and these are some of our semiconductors. And you see these ones are yellow. It's a semiconductor, and here you have, let's look, what do we have? Aluminum, what is Au, what is gold? Go somewhere on here. And iron, copper, so they're all in this area. This is iron, cobalt, these are the metals, conductors. And here we have the semiconductors, and the edges we have the polymers. Okay? Don't think about it too much, just to show you it's some kind of relation. So there were 110, now 118. We keep discovering new material and adding it to the periodic table. I need you to know metals are conductors, rubbers and polymers are non-conductors. And if we go back here, you see the carbon atom, which is the basis for all what products? Okay. Plastics, rubbers, organics, so they're all in this area, which is non-conductor. Semiconductor, silicon, and we go here and we have metals. We have cobalt, we have nickel, we have iron, zinc. These are all metals, so they're very conductors, semiconductors, and non-conductors. Okay. Every element has different mass, different charge, and number of electrons. Intuitive. We're not doing chemistry here, we're doing electricity. Molecules are composed of what? Two or more of elements together. So water is an element or a molecule? Molecule, because it has H2O, two hydrogen and 1 oxygen. Okay. CFC, which you're gonna see in refrigeration, Again, it's carbon fluoride and carbon or chloride, so it's a molecule. So the definition of a molecule has more than one element. An element is just a single, simple element. Any questions so far? We're not going too deep into the science. I just want to explain the idea of electrons, and that's from electron comes electricity. It's energy. So the atom is solid in the middle, and there's something around it that's energy, and that's what we are using to exchange energy and make electricity. Conduction depends on the number of the electrons in the last orbit, which makes metals easy to conduct because they have a loose one electrons or two at the end, which you can knock out easily. Carbon atom has 4 electrons in the last orbit, which makes them more stable. You agree? It's easier to knock 1 electron than 4, so they make them very hard to conduct. However, with the right voltage, you can knock those 4 electrons. However, again, 1 is easier and 2 is easier to knock out. Silver and copper have 1. That's why they are very good conductors. Of course, the best conductor ever is gold. But nobody will make wires out of gold, right?
No.
Silver is also a very, very good conductor, but again, nobody would make wires made out of silver.
Where's
So
platinum?
copper, huh?
Where's platinum come in there?
Platinum is gold with some higher order of gold, and it's also very, very good conductor. That's why they call it noble metals. Insulators have 4 or more. So you see the relationship, more electrons, hard to knock out. It's really difficult to displace. Single and double, that's another thing we'll talk about. Some metals have single, some of them have doubles, and that also has a relationship. I'll show you a very old video, but it's very informative, that tells you what is the difference between having 2 electrons in the last orbit or 1. And that's what makes things magnetic or non-magnetic. Like for example, if you have a magnet, it will work on nickel, it will work on iron, it will work on cobalt, but it will not work with brass, right? It will not work with copper. You cannot, with a magnet, you cannot attract gold, right? And that has something to do with the two electrons in the last orbit. Electrons are negative charge. Proton, positive. Agree? Anybody's confused, raise your hand. It's all just introduction. Just if you know this concept in a nutshell, I'm very happy. So the mass, what gives mass is the nucleus. And again, till this day, nobody knows what is mass. In the Large Hadron Collider, they try to bang 2 protons by each other and break them out and find what's inside. And they found a bunch of stuff they're trying to name and identify. So people are still trying to find out what is actually mass and what is actually gravity. And as far as I know, latest update, there are some breakthroughs, but nothing is still solid. And again, if you took some chemistry or physics in high school, probably you read about Faraday and Rutherford and them trying to find what's inside the matter. It's been a challenge because again, it's very, very small and it's hard to know. We cannot see it. We just have to see the effect of it. It's very, very small, even with the biggest microscopes. At Cornell, they have electronic microscope, which actually you can see the molecules of metals coming together. It's very, yeah, you can see it. You'll see it actually visually. You run it through a computer. The computer will process it, and you'll see a picture of the molecules of the metal bonded together. So mass, every atom has mass, charge, field. By field, we see the distance between of the electrons from the nucleus. So it's going to be a big field or small field, and that depends on the number of electrons it has, and the number of electrons depends on what? What do you think? The number of electrons around an atom, around a nucleus, depends on what?
The amount of protons.
Yeah, thank you. That's why the Earth has 1 moon, and Mars has more than 1 moon, and Jupiter has 3 or 4 moons. The bigger the mass, the more you can attract things to orbit around you. So the amount of proton, the mass you have inside the nucleus, the more you have things around you. Frequency, just the field. Frequency is how fast they go. Makes sense, the small orbit will go faster than the biggest orbit. Okay, enough science, let's move on. So the flow of electrons is what we call electricity. So if anybody asks you to define electricity, it's the flow of electrons through a conductor. So let's think about it this way. If we have, it's going to be very abrupt, arbitrary. We have these atoms, we have around these small little electrons. And you go in here and you introduce one electrons, you're going to knock one out into this atom. Then you knock another one out because the atom wants to be stable. So you're going to push that electron out, introduce a new electron, and electron is just a charge. You charge the atom, so it's going to have extra charge. It's going to feel agitated. It's going to want to give that away, so it will be imbalanced again, so it will give it to the next one, and so on and so forth. It's like a wave. It's like you're sitting in a stream of water, and you make a wave. Doesn't it go at the end? It will go to the end, right? If you throw a stone in the water, you see a ripple effect. That's what you're doing for electricity. So it's required force, it's like the flow of water. The water is very stable, but you go there and you push, and you'll move something very far away from the water. This is the simplest example I can come up with. So friction makes sense that you will have friction and you will move electrons, and that's what John was saying. When you're wearing like wool or some kind of semiconductive material, the friction will move some electrons around, and you're gonna have a charge, and this charge is looking to stabilize. When you touch the doorknob, it's discharged. However, if you notice, it's a charge, it's not gonna be continuous flow. So it's nice, but it's not good for us to have a flow of that current, right? So it's gonna be just a charge. However, we do use that charge in capacitors. Capacitor is a big battery full of wool, sometimes oil, and we keep storing charge in it. Whenever we touch those terminals, we get the spark. So it's like you walking with wool pajamas, collecting charge, and you touch your cat or you touch the door, and you feel that little spark, and it is very strong in a way. So that's number one. Number two, ancient Egyptians and ancient Chinese realized that if you put some kind of acid material with some metal, you're gonna generate some kind of electricity that will go for a while. They have batteries made out of clay in ancient Egypt and some in China, and you can make a battery out of potato or a lemon. Yeah, and that will charge. So you'll see small light bulb. You can, because again, we're doing a reaction of chemicals and conductors, and you can make a small battery out of a potato. It has a lot of potassium, a lot of solution and conductivity, and it will light up something. And you can also see out of lemon. Lemon has a lot of acids in it. So the reaction, the chemical reaction, causes some electricity. That's what's happening in any battery. What you're doing in a battery is you have a paste, conductive paste, and two metals. Once you connect the two terminals, you are starting the reaction. Those little chemicals will start to unite, and as a byproduct of this new material happening, you have electricity. However, after time, what's going to happen? To reach balance, and you run out of charge, and the battery will go weak. With new batteries, you can charge it again. Different chemicals like lithium ion, give it some electricity, and you'll put the material to a different phase, the original phase, and so on and so forth. However, there's always a byproduct. That's why they have a cycle life for a battery, a rechargeable battery. They tell you this is 1,000 cycles, charging the charge. After that, it will lose ability to hold electricity. Because you have a small byproduct, 1% or 2% every time, a byproduct you don't want. So that's when the battery goes bad. And until now, all batteries go bad after like a year or two of continuous charge. Around 1,000 cycle, 500 cycle depending on the material. Probably you buy a cell phone, the first few months, you can hold the charge for 3 days. You notice after 6 months, it doesn't charge as well. After 2 years, it's time to change the battery. And by the 2 years, it's cheaper to change the phone than to change the battery. So that's what happened. So that's a chemical reaction, and that's batteries. What is friction? Friction is static electricity. You have a balloon in your hair, wall, that's static. Chemical is battery. Any questions? Magnetic. That is what we depend on. We'll talk about that more. Magnetic is when we have a generator or a motor. We basically use a magnet to move mechanically around copper. And somebody realized that this actually makes some kind of current. And that was the invention that made us actually go into the new age and know how to continuously transform mechanical energy movement into electricity, a flow of electricity. So before that, we can only do batteries, which doesn't last long, friction, it's only a spark. But with mechanical, we can use the power of a river, wind turbines, or just a generator to change this movement, cyclical movement, into current of electricity. Okay? The fourth type of making electricity is heating similar metal. Does anybody go camping? If you go camping, they sell those little pots that you put in the fire and it will charge your phone because of heat. So what happens is if you put two metals together, two plates, let's say one of them is copper, stuck to, has to be copper, the first metal. The second one can be anything you want, but it could be either nickel, sometimes nickel, iron, or cobalt, CCU, I'm not sure, CCO. And you heat it. What happens is when you heat those two metals, which heats faster, metal or copper? Copper. So the copper heats faster than metal. What happens is they're next to each other, they start to get aggravated with each other, and what happens is they generate friction and electricity. The amount of heat that each one of them is generating is different, so these similar metals will have different charges based on heat, and that will generate some electrical potential, which we call voltage. So if you put a wire here and a wire here, between those wires, if we measure, we'll find there is some kind of voltage, not too much, a little bit, maybe 1.5 volts. And we can use that. We use it for making electricity. Some people are working on making this into something very tangible. We can put it in the desert and it will generate electricity, but so far it's very, very small. We have something called a thermocouple that we use in all our HVAC heat measuring. This thermostat has a thermocouple, which basically the same thing, same idea. However, it's just a wire. Two wires touching each other, and at the tip, whenever there is temperature, it will generate voltage. And we know beforehand what voltage it will generate at each electricity, and we translate that into electricity. Question?
So is this how solar power works, is by heat?
No, that's solar panels, they react with photons.
So
Yeah.
which would that be, say, before?
That'll be also chemical.
Oh,
That'll be chemical because again, the silicon will react with the copper and make some electricity. So it's kind of chemical. However, it's different kind of chemical because again, we're not having byproducts, but it goes under chemical. And now they're trying to couple that with heating two similar metals in the same sandwich. We'll talk about photovoltaic in more details. But these are the four types. I'm sure there are more, but these are the four most common types that you can generate electricity. And the one we depend on for power generation for our houses is magnetic. And that's what I want you to think about. And it's a little bit intricate, and how somebody came up with it is just amazing. And that was Faraday, where actually he realized that copper, even though it's non-magnetic, it will react with steel or metal to make some kind of a magnet. It's okay. And every wire that has electricity going through it, it has magnets. So was very fascinating. Took a lot of trials, a lot of setup, until he finally came up with an idea of keeping something moving and generating a flow. And that's what we want. We want a flow. Now we have flow going all through the room, flow going through all equipment, and this is what we can use. And with flow, you can use rivers again, you can use wind, or you can use a generator. What is a generator? It's a combustible engine. internal combustion engine. Your car is generating electricity through the alternator.
Yeah.
It's using internal combustion. So we'll talk about that as well. But these are the four types, four most common types. And if you have any questions, let me know.
What's internal combustion?
It's burning stuff in the chamber. That's your car engine.
So like the air and all the stuff that's just inside the car?
Yeah, everything's it's being burned inside internally, and it goes through the muffler. So we have a chamber, and we put all the stuff we want in it. We burn it, and we use that expansion to make yeah.
Gas and electricity.
There's also external combustion. That's a jet engine. Where it burns everything together and goes out from together. Yeah, we're not using a chamber to compress anything. I think it's technical terms, external combustion. Internal, like we put it all in the chamber. So, more details, static electricity, which John talked about, is caused by friction, but there's no steady flow. Once it balances out, it's gone. Once you touch the doorknob, you no more have that charge. What do we have that in our field that relates to that? We have something called a capacitor. Hopefully I have one, so I picture that. Here we go. This is a capacitor. This one is filled with, I think, oil. This one is also filled with oil. Same material that will hold a charge. So you'll see this in a lot of motors. They just have a big charge, and if you look at it, it says microfarad, MFD, which is the amount of charges in it, and how much voltage. How much joule it give you. So it give you one big charge, and it holds static electricity. And the purpose of it, many things, we'll talk about that again for a whole week. We'll talk about capacitors. But they do hold a big charge, and I will show you how to discharge them, because if you see these, even if the equipment is disconnected, and you see it, do not touch it, the spark is very strong, it can burn.
What can you normally see them?
Huh?
Where can you normally see them in? Like, what type of
Every AC. Every AC has a capacitor. Your car has a lot of capacitors. Any motors, a lot of motors have them. They use that charge to kind of give it a kickstart.
More motorcycles, right?
Yeah, yeah. So just be careful when you touch them, because they have a lot of charge, depending on the size. And one way you can find if it's functioning or not is the shape. It leaks oil sometimes. And usually in the beginning of the season, when you go turn the AC and the AC is not turning on, probably the capacitor went bad throughout the winter. The extreme cold might damage it, and it's always outside. So once it balances, there is no more flow. You have to recharge it again. And it dispenses the charge all at once. Once you touch terminals, you get 400 volts right away. Batteries. You can talk like the whole semester about batteries, but basically what happens in a battery, we have two electrodes. Did anybody ever took apart a battery out of curiosity? Yeah. I made a mess and somebody yelled at you for that, and you're not supposed to open it because it's very toxic. Yeah, yeah, I did that. I love the little rod and like the oil paste, it's all over the place. So those the electrodes. If you pull the top, you'll see a rod. On the bottom, you see a metallic side, and the middle. What is in the middle? A paste, right? If you squeeze a battery, like a regular alkaline battery, it's very squishable. You can squish it. When the battery goes out, we put it around our teeth and press, and it works a little bit more. What you're doing actually is making the paste that's wearing out touches more and you get fuel out of it. But again, don't do that. That's wrong. Yeah. I did a lot of bad things I didn't know, but I'm gonna have a kid one day with 3 arms. But that's a no-no. And
that's true. I remember that.
yeah, they bang it on the crooks, right? That's what's happening. And there are very strict regulations when it comes to lithium battery disposal. Please be careful with the rechargeable batteries. They're very toxic to the environment. Be very careful and conscientious about it, because it's really bad for the environment to dispose of these things, and it costs a lot of money to dispose of them. And this is one of the big arguments against electric cars, is the disposal of these batteries. It's highly toxic chemicals, bad for the environment, so we have to dispose of them properly. And the school here has receptacles for rechargeable batteries, so please be careful about that because it's really bad for the environment, and we have them everywhere now. So put them in a bag, in a container, and take the extra step and take it to the proper place because lithium ion is very, very bad for the environment. Electrolyte? Gatorade, right? Sounds like Gatorade. Electrolyte. What's electrolyte? Huh? Something you drink. What's in it? Salt and water, right? They're telling you Gatorade because it has some salt, electrolyte, things that conduct electricity. He's drinking it right now. Yeah.
How can Gatorade make you more thirsty?
Huh? The salt.
So,
Salt. Salt makes you drink some more water. So you need the salt and you need the water to keep your body functioning, as we said last class, because your body is made out of electricity. Electricity makes the muscle twitch and also conduct things in your body. So electrolyte is something that is conducting electricity. Otherwise, there's no conductivity. And I talked about the experiment when you have a glass of water, distilled water. What is distilled water? No salt. And you put a battery, connect to it in series with a light bulb, and there's no light, but then you keep adding salt and the light starts to come out. Question?
So if I wanted like electrolytes, I put some salt in water and drink it.
Yeah, but again, the salt, you can put some table salt, which is fine. You need some salt. You need at least 3 grams a day.
There's no salt in like regular just water, like
Say that again?
faucet water, there's not salt.
No, it has some salt.
Yeah,
It has some salt. Unless you have distilled water, there's no salt. There is some salt in water. You don't need much. And actually, they sell some solutions now with a small spoon. If you work out a lot, if you work outdoors for construction, that require, but I'll give you water with some salt in to replenish, especially if you're sweating a lot. Otherwise, you get a heat stroke or you can pass out for lack of salt. So in your body, so you need that. So substance that it's ionized when dissolved in suitable ionizing solvent, such as water. This includes the most soluble salts, acids, and bases. Some gases, such as hydrogen, is also electrolytes. And the condition of high temperature, low pressure can also function as electrolytes. Can you give me an example of that? Of gases being ionized and conduct electricity?
Neon?
Huh? Goes in light. If you look at this light bulb, it has gas in it. What is the gas? It's a combination of mercury and helium and other things. So I tell you, be careful disposing of this light. It has some mercury gas in it. What else?
That's what that powder is then.
Huh?
That's what that powder is?
Yeah,
Okay,
yeah.
all right.
What else?
Neon?
Neon science is all neon gas in it. They're being agitated and they put some coloration in it to make it color. What else? What about the screen of your phone? It's plasma, right? No, not really. Probably it's LED. The TV, the plasma. Each cell of those has small gas, plasma gas or liquid. That at certain temperature it will turn to different color. And that's how you have plasma TV.
I thought they don't make plasma TVs anymore.
No, I don't think so. It was a bad idea anyway.
Yeah, well,
It wasn't that good. Somebody bought it. Chemical reaction that produce flow of electrons to a new substance, that's battery. So when you conduct those two terminals together and they react, eventually you get electricity, but you get a new product. Make sense? If you do the right material, you can reverse that and put electricity and get the original product with some new product you want. Eventually, it will wear out. Dry cell battery is made out of zinc as negative electrons to give away electrons. So I don't know if you guys remember that, but probably John, you remember the batteries with the little cells, the car battery,
Yeah.
where you buy it dry, then you have to open the little eyes, little container, and put some acid water in it, and you might burn yourself. And within 6 months, you have to change the water. It was a very pain in the neck to do that, and sometimes it oozes. So that was the old batteries. They were doing the same thing. However, it has more recycling. It lasts for 2 years, and it's acid base. It has some zinc in it. It has some magnesium in it, and lead to facilitate that reaction. Those was the old car batteries. We don't do that anymore. Now they have better technology with lithium ion, and they are more expensive. Those batteries are like $40. Batteries nowadays are $300 for a battery.
Buck 50,
Huh?
about 150 bucks.
Yeah,
For a cheap
but they
one.
last 7 years.
We have core charges too,
Yeah.
so if you bring the old one.
And you don't have to refill them anymore. They do not leak. They are safer. So that was a type of battery that you can charge, and
They still leave the caps on though, you know what
Yeah?
I mean? Yeah,
Some-
you can pop them off still, but
Some of 'em-
they don't need to.
Are sealed though.
Yeah.
Zero maintenance, the cap
Yeah.
will come off.
Yeah.
they're supposed to be like zero maintenance and it's safer, but that's recent in the last 10 years. So manganese dioxide paste is sometimes electrolytes in some batteries. That's the case, the black paste you see in the battery. Carbon rods, again, if you take away a battery, you'll see a carbon rod in the middle. So this is, again, battery is a new science, yeah.
What's that second thing? Second to last bolt said.
Second one,
Yeah, second to last. Yeah.
manganese dioxide paste is the electrolyte. In some
I can't
batteries,
even say that word. What's that word even mean?
manganese is an element. You don't have to know this.
Alright, word.
It's just introduction. So it's manganese, it's some kind of a chemical substance as paste, it acts as a electrolyte. I just want you to know the concept. What I want you to know, a battery has some chemical in it, this chemical reaction,
Dirk,
once touched, it will give you electricity. Okay?
I'm watching a video on YouTube like last week, and the guy walks in the store, he got change from the cashier, he had his his vape thing in his pocket, and it exploded.
Yeah, probably you
Two-
touched something
two
wrong, the
connections,
wrong way, yeah.
yeah.
So, again, and the thing is, like, new batteries now, they have more
Huh?
charge and more oomph to it than in the past, so you better be careful on how you
Crazy
charge
big
things.
explosion,
There are batteries that have liquid in it. There are batteries that have paste. Again, what did I want to say? Yeah. And some of them,
Yeah.
they used to collect electricity. You have to charge it. Some of them have some kind of solar panels on them to charge them. And who saw Breaking Bad? Yeah, so you saw when he buried the battery in the ground? That actually works. You can bury a battery in the ground. Why? Because the ground has a lot of charges in it. And eventually it will get charged. And sometimes if you warm the battery, it will work better. Why sometimes in the winter, if you have the old batteries, the car will not start? The battery is not really new. Yeah, because temperature, electricity is related to temperature. The hotter the conductor are, the more they will conduct. To a limit, then it starts to conduct less. And the chemical reaction will change inside the battery, especially if it's liquid battery. It's really, really cold, low freeze.
How come people used to throw batteries in the freezer?
That's what I was just gonna ask.
You try and slow
My
down.
mom used to tell me to do that. Put the battery in the freezer.
I don't know. I don't think it's necessary with the new batteries at all. But that will slow down the reaction with time. The new batteries now you buy, it says 10 years guarantee, saying in the pack, without freezing or anything. The old ones, you have to slow down the process. Go ahead.
Water in the battery.
Yeah. No, even the remote batteries. I saw people taking out the batteries and putting it in the freezer.
Well, like your car battery, once it freezes in the wintertime,
Yeah,
it's
right.
really low temperature, it just stops working.
Yeah, because there is no more
You
conductivity.
can't.
So, going back to the Gatorade, if you freeze the water, there's nothing moving inside. So, it does not function the same. So, again, battery is a whole science. People, guys, questions? So there are science and there are people trying to come up with new batteries, and there are research centers only into batteries. Because why? If we have batteries, we can make solar power and wind turbines run everywhere. Why? Because we can store things. Because the wind doesn't run when you want it to. So in the middle of the night you need electricity, but the wind is running, so I can store that in the battery. So battery science is a whole field, and it's getting much, much better. And we have to always think about recycling and what is the aftermath of having those batteries. If you buy a Tesla, have the price of the batteries. Have the price of the batteries.
Well, I know like the Toyotas, it's like $5,000.
5,000 for the battery for the hybrid. Yeah. So and there's a lot of stringent laws. It has a number on it. You're responsible for the batteries. You can't just throw it away in the woods. You gotta recycle it, and they are responsible for that. And it lasts for 10 years.
Yeah.
So financially speaking, it makes sense. But that's 5,000 for Toyota. For Tesla, I think it's 30,000 for the battery pack. So the car is 55, but more half the price gets the battery.
Yeah, but if
So,
you buy a car, most likely you got the money to repair it.
Yeah, I guess so.
You're not gonna buy it without the money.
So this is what a battery looks like. Who asked me what that? This is the carbon rod. These are the outside of the battery where you get like that connection. Once you connect this side to this side, we have a complete circle, and we start the reaction. as we go. You discontinue that, this is the electrolyte paste, carbon rod. We have, if you open the battery one day, don't do it, look at YouTube, somebody did. You see like a big, small folio sheet with paste in it, and turn around like a Swiss roll. And this is the manganese. This is the manganese we're talking about, and zinc sometimes. And again, they have improved a lot, and that is now lasts for 10 years within the pack without any going bad. Okay, I think that's enough for today. We'll continue on Wednesday.